So today we're going to start by describing the, is that okay? Okay. So this usually when we teach this class will be dedicated to Dr. Shen. He will be delivering the whole lecture. But on his behalf, I'm going to use his lecture notes, integrate a little bit of my own work to explain the process, okay? So forensic, the word forensic means public, okay? It means a public forum. So a very important aspect of forensic engineering is really to stand up and defend your case in front of the public, okay? And so that is why our exercise in this class, the project is to have you guys come up here and defend your work, okay? And forensic engineering, so it's an interface between engineering and really the legal profession, the law, okay? And of course, most of the activities that we will be doing has to do with investigation, okay? And so either today or tomorrow, if we can finish a little bit early, then what I propose we do is we go to the civil engineering department, okay? And we will look at the building, okay? I'm not going to deliberate too much, but we will see what are the problems that we will actually observe, okay? And so as I mentioned, your goal is to define if the building is safe, limited use, or unsafe, okay? And so you can either quantify the building as if it's entirety safe or partially safe, okay? You can partition the building into different components, okay? And the reason why we want to give you such a liberty is because in a real life setting, many times as the professional engineers, you are at the liberty of defining the scope of how elaborate you have to do your investigation, okay? And that is extremely important to realize because it all ties to the dollar values. In other words, how much money is the client is willing to spend on an investigation, okay? I will be, not today, but on Thursday, I will be showing you some of the instrumentations, if you will, for inspection. Okay, some of those are new technologies, and they are not cheap. Okay, and so the client may not be inclined to ask you to do those kind of investigation, and that really limits on what you can do. Okay, as the investigator. Okay, and so you have to start realizing that many times the lawyer actually dictates how extensive your investigation can be, okay? Sometimes they even, okay, so one of the words that I'll be using a lot is legal binding. In other words, the moment that the client approach you about a case, okay, the conversation that you have with the client becomes a record, okay? Documented or undocumented, it becomes a record, okay? Because many times, one of the court's operation is to making sure that there is no foul play. In other words, you're, as the expert, you are not hired to hide facts, okay? But because the process of interactions and also clientele privileges relationship, sometimes it becomes murky, okay? And as a result, many times when you are being approached by a client, okay, especially if the lawyer has the tendency of trying to coach you in what you do, okay, and when you are younger professionals who do this kind of line of work, you tend to be taken advantage of, or you tend to be being controlled by the lawyer, who would be much more experienced than you, okay, and so it changed the dynamic of the interactions between you and the lawyer, okay? And so it becomes extremely important, and the court usually will make sure that you know nobody cross the boundary to the other side, okay? And so many times as a result, the lawyers become very, very cautious in how they interact with you. There are a number of cases when the lawyers approach me, I ask them, do you want a final report? Sometimes they will say, yes, please document whatever you have found, but don't show me, or don't let me know that you have these notes. Okay, because if you have certain notes, then the court, by the law of information, can demand that note from you. Okay, so if you, for example, there's a case that you are not very certain, okay, and then you are on the fence about the opinion, your opinion, one way or the other, and the lawyer come and nod you a little bit to one side, you did, then there is an issue, okay, because you have a change of mind throughout your investigation, okay, which is perfectly fine if you are allowed to be open, okay, but that may hurt the case for the lawyer. Remember, his role is not to defend the truth. His role is to defend his client, okay? He worked for his client, okay? And so that becomes a critical, significant point. And that's why the lawyers sometimes want you to do an investigation without taking any notes, okay? Because any notes you taken, the court will investigate, okay? And then they will be asking you, oh, yeah, you're right, there's a crack here. Why did you say there is no crack, okay? Then becomes complicated, and the lawyers would, sometimes tell you not to do so. And so it becomes professionally a challenge, okay? And also, as engineers, we have the habit of collecting data, right? And some of us are sometimes, for our own learning purpose, we may want to keep it for a long, long time. I have friends whose basement is full of evidence over the years, okay? And sometimes that's not allowed, okay? Because anything that you keep and preserve may one day be exposed, okay? And so those are all the delicate, critical elements in the professional life of a forensic engineer, okay? And furthermore, there is also cases where you are not allowed to discuss a certain case, okay? And so everything that I show you are, to some degree, even though I have not asked my client whether I'm allowed to show, but I think many of the cases I'm showing are already historical. Or I only show you part of our data so that for the purpose of communicating knowledge, okay? So I'm not disposing what I found and also what happened, okay? And so that way I can protect myself. If anybody ever seen the GIAN video and say, hey, Dr. Chen, you discussed this particular case, then I can be protected, okay? Does that make sense to you? Okay, so even though I'm doing all this in India, it is very likely somebody overseas that I have involved in the case, they may find out what I'm doing here, okay? And so I have to be very careful. And so if some of my presentations doesn't show you the whole story, okay, we can discuss afterwards, okay? So, but that is the nature of our work, okay? So you have to understand, for engineering profession, this is probably one of the highest levels, okay? And that is also one of the reasons why we're doing what we do, okay? Because we need to let people know what this profession does so that you learn, okay? And unfortunately, to convey what we know into useful information, we have to use case studies, okay? And so at the end of the lecture, I will discuss, what the academia or the universities are doing at this stage, okay, of this kind of investigation, okay? Experts, okay, so when you are being hired to do an investigation, you are being, yes?
Sir, I have to ask that in India,
Uh-huh.
there is no such law or like a business according to the client and that. So what is the use of that forensic investigation in India?
Oh, actually, I disagree. Okay, I disagree in the sense that I think there are laws that require expert opinions, even in India. Okay, even though it's not defined as expert, I mean, even though it's not defined as forensic engineering, okay, there is certain requirements by law that you require experts to dispose information and investigation. Okay, so it is not entirely true, and that is why one of the things that we are trying to get an understanding. Okay, because there is always litigation. Okay, any country as a country, okay, in the ideal sense, will have law. Okay, and the purpose of the law is to provide justice to any litigations, okay, legal fights, okay, and so that law would require certain forensic practice, okay, and but it will vary different levels, okay. So India, like every other nation, will have some people involved in this line of business, okay. But because you don't have organizations, or you don't have, in other words, it's not fully organized. And that is the challenge. Okay, so when a lawyer has a incident happen, okay, like the Mollyvacum Chennai building collapse, okay, they need to, there is lawyer always involved, okay, on either side. And that lawyer will have to find who are the qualified experts. Okay, and so I think in the case of India, they most likely go into either find a structural engineer who has been doing many designs as an expert, or go to the university, find a professor, a recognized name as the expert. Okay. And then it becomes the burden of the professor to prove that, hey, I am the expert of this area. Okay, so there is such process. It's not defined. Okay, so yeah, that is always the challenge, and that's one of the things that why we are striving to push for a forensic engineering curriculum that we discussed yesterday, is that we need to have the process formalized because it's so important. Okay, like I mentioned yesterday, like the World Trade Center, those are billion-dollar litigations. Okay, a lot of people's lives, and also people who already lost their life, the relatives of those people who lost their lives, are at stake. Okay, and so it becomes really important for us to be able to formalize that process because it's so significant. Okay. So in the America, experts are based on your training, okay? So when I was in BTech, we have a class that taught in forensic engineering, okay? And we are one of the few schools that actually teach that way early, okay? So several of my former professors are involved in forensics work, okay? But that was, 30 years ago. And then we slowly, through ASC, we found that there are other schools that I mentioned yesterday that were in one way or the other involved in the teaching of, in the forensic engineering education. And then so this is a long process, challenging process that we are getting involved in, okay? And you have to be active in technical area, okay? In other words, so this, like all consulting work, you have to let people know that you do this work. Okay, so getting involved in a technical association such as ASC or Indian Association of Structural Engineers is very important to make yourself known. Okay, and many times you may find in the Structural Engineering Association, you are the few. You always a few sit together. The rest of them are all doing designs or repair work and so forth, okay? But you will be few, okay? And that is because it's not well known that forensic engineering is actually a profession, okay? And then you have to be fair, you have to be ethical, you have to be truthful. Okay, those are really, really difficult elements in engineering ethics to define. Okay, because we have a lot of colleagues that are very easily influenced because they are in for the money. Okay, and as a result, you know, they tend to be easily biased. Okay, but our job is really not to be biased. Okay, so when you do a reporting of an investigation, you document everything that in your opinion, and you have to show how you form your opinion. Okay, that process is extremely important. Okay, scientific investigation is very simple. You do the work, experiment, you do the research, and the outcomes should be black and white. Okay, but in reality, we know that a lot of times you don't. And part of this lecture series is to show you some of the fallacies, if you will, okay, in logic as well as in the ability of collecting evidence. Okay, and so those are critical issues. And yes.
Is it important to have formal education in law?
No. Oh, it's almost impossible. We have over the years, I think I have only a few colleagues that have both law and engineering degree. Okay, and sometimes it works against you. How so? Because then the lawyers think that you become a basic conflict. Yeah, you have to understand that in the preparation of you being the qualified expert for a certain case, you should not have any conflict of interest. Okay, so if you have a law degree, you may become a lawyer defending certain client. Okay, and if that client has a relationship with a case that you are doing an expert engineer, then there is a conflict. Okay, so sometimes you wanted to keep yourself as pure as possible. Yeah, and so there are times that I would refuse cases because I think either I'm not qualified for, or I think there is a potential conflict, or I just think that I cannot do a good job in that case. You know, then I would recommend another colleague, or you know, or just refuse the case. Okay, so it is okay for you to refuse a certain case. Okay, you don't have to do all cases. Okay, so the legal aspects of forensics goes way back. Okay, so we will go through a few of those codes. Okay, so the Hammurabi is the oldest regulating our behavior. Okay, the engineer or professional behavior. Okay, so this goes back to 1700 before Christ, BC. Okay, and so the law says that, hey, if you build a house and if the house collapses and kills somebody, you ought to be killed. Okay, so it's very rigid, very stringent law, but it is at a time where most of the engineering practices or construction practices are by experience and not by true knowledge. Okay, so whatever that we do is almost secrecy. Okay, and I don't know if they make enough money even then, but apparently the responsibility is so severe that your life is at stake. Okay, and so today we don't necessarily have that kind of stringency, but losing your license, losing your career is something equally important in this day and age. Okay, and we will see some famous cases today. Okay, so you can see that if the collapse caused the death of the son of the owner, they need to put the son of the builders to death as well. So wow, like this is almost barbaric, but this is the law at that time. Okay, and then there are many more levels. Okay, so I think this was law was found written in tablets, stone tablets. So it's very, very archaic. Go way back. Okay, we have equally significant laws today that dictates our professional behavior. I'm not familiar with the Indian codes, but I'm pretty sure, if you build a house and that collapse, then you are responsible. Okay.
If such thing happens and it is proved, we will be jailed.
Yeah, we'll go to jail. Yep.
But not so severe. Like
Yeah. At least you're not being killed. Yeah.
After several investigations and other things, they will put the person in the jail.
Yep. Yeah. I heard a case. So this is in Saudi Arabia. Okay. Many years ago, there was a Korean company doing construction in Saudi Arabia, and one of the manager was driving, and he accidentally killed a person. So by Saudi law, he has to stay in jail until the son of that dead person is 21 years old. Then he would decide whether this person should be killed or not, or pardoned. So, every country have a different law. Okay, so if you were to practice across national boundaries, you need to know what their law is. Yeah, and so that is another very important point that brings up to the discussion early on. Okay, even though some countries they don't have so-called forensic engineering, they do have law regulate engineering. Okay, so by what standard that is you have to understand and learn. Okay, and so Napoleon law in the 1804 they also have similar code. Okay, so if you build a building, okay, and that building has to have a 10-year of warranty. Okay, so anything happens within that 10 years, you are responsible. Okay, so today we have the insurance. Okay, insurance is one that pays for the penalty. Okay, and so that is a new system that help resolve this kind of warranty issues. Okay, so and I'm sometimes curious, like Microsoft Windows. We're in, I don't know what version, so we're Windows 10, right? So throughout my career, I've been paying for many Microsoft Windows, right, software. But have we ever built a building and say, okay, this is version 1.0. Next year, I'm going to get more money, so I'll open a window for you. That will be version 1.2. It's really strange. Engineers doesn't work the way that software does, right? But I think, shouldn't we be making even more money? Just, food for your thoughts, okay? But another very important, so India and U.S. and many other countries are what we call the Commonwealth of England, right? So as a nation that's associated with English before, many of our existing national laws carry some of the characteristics of the British law, okay? And that's what we call the common law, okay? So in other words, if our law is not complete in a certain sense, we can always refer back to the English law and see what they recommend us do, okay? And this is what we call the common law, okay? So those are still exist in our system, okay? Every nation varies to a certain degree. Okay, so those are all critical legal basis of forensic engineering, okay? And then we're going into failures, okay? So failures definition can be very, very broad, okay? But it does not necessarily define a structure as complete collapse as failure, okay? Anytime the building or part of the building is not serving its function, what it was intended to do, you potentially have a litigation, okay? And we can call that dysfunctional component or structure as a failed structure. Does that make sense? Okay, and so that broadens up our business. Okay, so you maybe call in and do a part of a building, for example. okay? And then it becomes tricky. So even though you are trained as a structural engineer, you don't necessarily have the qualification for that door if it cannot close, for example, okay? And so you quickly realize that the definition of an expert becomes varied, okay? And that is why I think the American system of requiring that you have a professional license, engineer license, becomes a little more controlled, okay? So if you are a professional engineer, you can do a lot of work, okay, because you're licensed, okay? But some of the work you may not necessarily directly be an expert, okay? For example, I didn't manufacture 200 doors, but I can measure and tell you why that door can't close, right? There must be something geometrically changed to the door frame at some point. And that change is what dictates our understanding of the problem, okay? And if you can prove that is the cause, then problem solved, okay? And so those are the really critical issues. And then there are different types, okay? So based on what we discussed early on, so there is structural failures, functional failures, or ancillary failures. Ancillary failures could be, this room is not cool enough, too much noise, okay? When the building was designed, there's something that wasn't done right, okay? So we have noise issue or the temperature not being able to regulate, okay? So all these are ancillary errors that not necessarily be part of the structural issue, okay? However, and this is where it gets interesting. So the lawyer may very inclined to hire somebody who's an acoustic expert, for example, if we're talking about noise, okay? But the acoustic expert can tell you how bad the acoustic is. They can tell you where the noise is coming from, but that noise source may be structural. For example, the window was not designed the right, the drawing required the window to be here. Instead, they build it here and opens to the market. So that is, in a way, structural problem, right? And so, yes, even though we are not specialized in acoustics, but in some ways you are still related to the case, okay? As long as you can show you can solve that problem. You can, not solve that, but identify the problem, okay, and find the failure. And this is where the ASC Forensic Council also trying to emphasize that even if you are a trained structural engineer, it does not necessarily mean that you can be an investigation expert. Because investigation, by definition, involves a certain skill set, okay? And if you go through 4 years of structural engineering curriculum, there's not a single course that you have taken that qualify you for investigation. Okay, and so this is where we believe that we need to have a curriculum specific for forensic engineering. Okay, and we're hoping that through the project you will be exposed to at least to some level that kind of expertise. Okay, an example I can show you would be if you have a building basement, okay, and something happened. So the basement will be underground, right? And there is a document, the investigation technique, inspection technique, that shows you that, hey, if the crack pattern of your basement wall can tell you what happened, okay? Whether it was a punching shear because of the wall, the soil behind was pushing against the wall, or whether there is a shear failure because of differential settlements on different sides of the building foundation, okay? And so based on the crack pattern of your break wall, you can actually able to define what is the actual problem behind. Same thing with bridge decks, same thing with any walls or beam failure, okay? So those are the things that we can train our eyes to identify, okay? And then define what is the damage modes, Okay, so when we start talking very specific about structural or geotech failures, we will be discussing about the different type of failures or the mode of failures. And then you have to be able to define the structural system. For example, a dam is a system. Foundation is another system. And then mat foundation, deep foundation are different systems, right? They all carry different damage profiles. Okay, so those are the critical elements that we need to learn. Okay, this is kind of repeat. Okay, so safety can be a critical issue if your design fail. Okay, or structural failure, and then there are many different kinds of failure modes, such as collapse of formwork. Okay. During concrete placement. So this going to a little bit specific. Punching shear of a flat of a floor system or wall system. Okay, trench collapse, slip and fall on a wet floor. Okay, so the last one is more related to construction practice. Okay, or occupational safety. Okay, so some of us may be involved in safety that is more ergonomic, meaning related to the construction person's humanistic behavior rather than actual structural physical system. Okay, so accident can happen in many forms. Okay, and for construction management, construction safety is also a very important area. Okay, how the workers carry their weight. Okay, heavy equipments, how they operate the heavy equipments, whether that is ergonomic enough for them to work or you will hurt their back. Okay, all this can be considered as construction accidents. Okay, and so there is a very specific discipline in civil engineering that deals with construction safety. Okay, and functional failures. So again, functional failures is well documented in civil engineering, but some of them are more challenging to validate than others. For example, floor vibration. Okay, so if this building has excessive vibrations, it becomes an annoyance. Okay, it may not be collapse of the building, but you have to avoid people who work in the buildings to have any kind of disturbance, right? And unfortunately, if you wanted to learn more about vibration issues in the serviceability level, okay, you found that there are very limited data, okay, and the reason is because vibration, especially wave-based vibration, high-frequency vibrations, actually change because of the boundary conditions. Okay, so in a setting that you wanted to be able to detect where the vibration source is, that is almost an art. Okay, I know that Virginia Tech, Dr. Murray is an expert in this area, but the limits are only still, what certain frequencies and certain modes of vibration. Okay, and unfortunately, those would take a long time to investigate. Okay, and then acoustic, we mentioned air conditioning and the roof leak. All these are critical issues. Okay. Ancillaries, delayed construction, unexpected foundation problems, unavailability of materials. All these are not directly related to structural or geotech problems. Okay, but you as a structural and geotech problem, you have seen enough of those problems that you can probably do some investigation. Okay. And here is a breakdown of the causes of failures. So in every nation, there is always a data bank on all the failures and accidents that happen in related to construction. Okay, so you can see that design deficiency has the most dominant in dictating failures. Okay, as the cause of failures. Construction errors, 20 to 25%. Material defects. Okay, whether you so in India, most parts are very hot, right? So when you mix concrete, you don't have a lot of issues. But in America, sometimes when when you're trying to cast concrete in the winter, the heat of hydration will not be able to completely release because it's too cold for the concrete to form. Then you have a lot of failures, okay? And so, if you were to investigate those kind of cases, you have to prove, one, the heat of hydration was not complete in the concrete, okay? And two, they have not performed the proper. So especially with the Department of Transportation, they have very clear regulations. If you were to cast foundation for a bridge during the winter, you have to provide the heat pads or material that makes sure that the concrete will form at the ideal temperature. Okay, so those are the things that much easier for you to process as long as you can prove that is the cause of failure. Do you have a question? No. Okay. Yeah. And then maintenance deficiency. Maintenance deficiency is much more difficult. Okay, because you have to have a record of when and how the problem happened. Okay, and so we will be looking at the I-35 bridge case, which I described a little bit yesterday. Okay. So we'll go through a few famous failures. Okay, so the Tower of Pisa did not fail. I mean, did not collapse, right? But it definitely has failures. So it's a 200 feet tall building, and it has been inclined at 5.5 degrees since the 1100s, okay, AD. So almost more than 1,000 years, the building has been declined, okay. And the fundamental problem is this was a structure built on clay, okay. And over the years, because of the differential settlements, the building starts to incline. Now, there are a lot of investigation being done over the years, okay. In fact, every so often, the Italian government will still require people to do investigation, but they are not in a hurry to correct the problem, okay, because it's not collapsing, okay, but they do wanted to make sure they always stay in that incline, okay, and so there are some earthwork being done in this case, okay, and but nobody has till today that wanted to make it straight up, okay, so this is a very interesting problem, okay, and then the Tay Bridge in Scotland in 1879, it was built in 1828, and it's a very long bridge, okay, and it has 85 simply supported iron truss spans, okay, and the failure happened when it had a major storm, okay, so there are a lot of storm surge and wave impact, and 75 people died, okay, and fair or not fair, okay, the cause of failure is designated to improper estimation of wind force, okay, so it's highly questionable at that day and age. We don't have a strong understanding of the aerodynamic of bridges, okay, but the understanding is that the bridge collapsed because of strong wind force, okay. So this brings to another very interesting concern, which is the Tacoma Bridge, as I mentioned yesterday, that the bridge has recently been publications that shows that the resonance is not necessarily the case, okay. In fact, we will talk about that at the end of lecture in more detail, okay. The 1981 Hyatt Regency building collapse in Kansas City is a really critical case in the American engineering history, if you will, okay. And what happened was that this case is being recognized for several significant contributions. So the building was built in 1981, okay. In fact, the accident happened right after the building was completed, and they were in the grand opening, and a lot of people come and visit, okay. And so the two walkways, as I showed in the picture yesterday, okay, a lot of people were standing on top, and then suddenly it collapsed, okay, and killed 114 people, okay. Now, this was at a time when we don't have any regulations on. So at that time, a lot of the dead are actually ladies, okay. And so when they fall from higher up down, their dress was not proper, okay. So this is the first time at an incident site they actually covered the body because to show respect for the dead, okay. So many of those things, we were not prepared for this kind of accident, okay. And so this is the first case where we show respect to the dead. But the interesting thing about this failure, and today is still debated, okay, is that and a lot of teacher who teach, especially in structural analysis class, that they will show you, oh, this was the design. And so what happened was, during the construction, the original design was very difficult to connect, okay. It basically involves a steel rod, and then you have the deck bolted to the rod, okay. And because of the construction challenge, the contractor requests, the steel fab requests that there is a change of the design. Well, the engineer didn't pay strong attention. They just approved. Okay, the engineer of records just approved. And I think the engineer of record at the time was just fresh out of school. So he didn't realize that this change of this design could be a safety issue. So he just approved that design, and without any documentation. Okay, and so that becomes an issue. And then when the building collapsed, so this is the design, okay. If you pay attention to the right-hand side, this is the afterwards design of the section. So original design was that this was a continuous to the second level, and then the modified design actually have them separated. I think the next picture shows, yeah. So at the original design is a through rod, continuous rod that have two decks connected to it. And the contractor think that is too difficult to do, and so they suggest that we have a discontinuous component. And so today, in a lot of structural engineering courses, the instructor will come and say, hey, that discontinuity was the problem, okay? So we should have designed this way and that way. Some people were claiming the bow was not big enough and so forth. But in reality is that when you look at the failure mode, okay, you can see that the section, the connection section failed, okay? And the bolt obviously was being pulled through, okay, on the top part, okay? But regardless of how exactly this design should have been done properly, there is a contractual issue here, okay? And that goes into the responsibility of the engineer of record, okay? What is their role in the actual incident, okay? And so what happened is the company that was the engineer of records, the Jack Gillam and Associates, they approved the final drawing, and they were found to be negligent, misconduct, and unprofessional. Okay, and so everybody in the company lost their license. The company closed. It became really, really sad. In fact, the owner, Jack Gillam, would travel around America, or maybe even internationally. He's still around today. He's an older gentleman now. But he would teach his failure as a lesson learned for many, many young engineers. Okay, so during one of our congress, we actually asked him to come and present his case. Okay, and so it is really sad, but this gentleman is bold enough to share his failure to the rest of us. Okay, and that, I think that is a professionalism that is unparalleled, and should encourage many, many of us to be more responsible for our work. Okay. And and as a result, ASCE actually passed a resolution that required the engineer of record to have a huge responsibility, okay, during this kind of litigation. Okay, so we as a profession require the engineer of records to be responsible if such case would to happen again. Okay, so The West Virginia cooling tower in 1978 is a construction failure. Okay, so there is 2 towers were to build identical, and one of them collapsed. And it's a big water cooling tower. Okay, and 51 people died, and the scaffold was anchored to the concrete wall. And when they were doing 24 hours of concrete placement, suddenly the concrete collapsed. Okay, because the scaffold was tied to the concrete wall, so everything collapsed. So as a result, this is the completed tower. This is what it's supposed to look like. Okay, and you can see this is the ground support. Okay, and the collapsed structure, you can see the upper level. So it was during construction, the upper level collapsed, and then all the debris fall within the confinement. Okay, and this is what it shows within the collapsed structure. So a lot of the people were either killed by the falling debris, or they were on the scaffold and they fall. Okay, but anyways, so this is one of the cases where, if you were a forensic investigator, you can go in there and then you identify the problem. Okay, but who should you designate the blame to becomes really critical. Okay, and usually, fortunately, it's not our job to say, oh, the contractor, they're at fault, this is what they have done, and so forth. But that's the lawyer's job. That's the court's job. Okay, the judge's job. But we'll have to show them that, hey, during construction, the concrete wasn't cured, wasn't have enough strength, and then all the scaffold, because they are tied to the concrete, they collapsed, and as a result, this is what happened. Okay, so should they have done the job properly? Maybe that they shouldn't make the scaffold and the concrete too much bonding or interface. Okay, so there are many important lessons can be learned from one single failure case. Okay, so the process of defining or failure investigation is that you first of all have to state the problem. Okay, and sometimes this becomes a tricky part because something happened. Okay, you go into the site and the site is a mess. Okay, so it will take a while before people start realizing, what happened here. Okay, and so many times when the forensic investigation is being involved, okay, you may hear many different voices. Okay, somebody will tell you, oh, the retaining wall failed. Okay, somebody will tell you, oh, the concrete failed. But you as the investigator, you need to be able to quantify that problem. Okay, I have a construction of a retaining structure. It failed. Okay, then on your own opinion and based on your investigation, then you start pinning down problems, faults, and so forth. Okay, and so that statement of problem is really critical. Okay, and once you have the problem stated, then you have to collect all the observations. You go into the site, you find, oh, there are a lot of debris on the ground. What are the debris? Concrete materials, steel members. You start documenting what happened, and then after you collect your initial data, then you have to start forming your hypothesis. What happened at this location? Okay, what was the thing? You have to mentally going back and envision the incident and how it happened. Okay, and then once you have your hypothesis formed, you start making the connections. Okay, I have made these observations, and these observations would fit to my hypothesis or not. Okay, so you start drawing a logical diagram, a flow chart, if you will. Okay, this is what happened, and this is not. And then throughout that process, you start to organize your evidence. Okay, I found a cracked window. Okay, that cracked window was probably due to the window frame being deformed. Okay, so what caused the window frame to deform? All part of the wall has collapsed, or it pushed down because the beam on top has heavy loading. Okay, you start forming those, and then you start organize your evidence. Okay, and in the process of doing that, you have to recorrect yourself. Okay, yeah, my hypothesis may not be reasonable. Okay, I think this is what happened, and I think that's what happened. Okay, so this is a very natural process of you performing your logic, your reasoning. Okay, but it's also a very important point that at this point you should not come out and say your specific conclusion, because you're still in the process of forming your opinion. Okay, so the lawyer sometimes may push you. Okay, they may call you very frequently and say, "Oh, okay, Dr. So and so. So what is your finding?" I'm almost certain myself that party A was the problem. They have not done this. They should have done this. What do you think? At that time you probably should be more conservative and tell them, "Well, I thank you for your opinion, but I'm still forming my own opinion at this point." Okay, and it is also a very tricky time, because sometimes the lawyer may be tempting you. Okay, trying to see where you stand one way or the other, because they may terminate your contract because they realize that you're going in a different direction. Then they will say, "Okay, thank you, Mr. So-and-so, for your service. I think we're done here. Okay, I'll pay you for this many hours. Please send me your bill, and I'll pay out." Okay, but we will no longer require your service. So it can happen. Okay, but that is okay. You still hold to your true self. Okay, your professionalism. Okay, and after you analyze all the data and you have certainty of your findings, then you make your conclusion. Okay, and this is really a good time for you to communicate to your lawyer and ask, "Do you want a final report?" Okay, I have my notes. Okay, I have my information. I can formalize everything and give you a final report, and that you can submit to the court and say, "This is our case, and this is where we stand. Our expert opinion is this." Or they can just say, "Well, are you ready to go to court and just defend?" There are many directions. They may want to arbitrate. Okay, so because in the legal process, many things are very dynamic. Okay, we don't necessarily control the situation. So most of the time we are the waiting party. We wait for the lawyer to tell us to go one way or the other. Okay, I mean how to proceed. Okay, and so at that time you just have to be patient. Okay, some of those litigation can go into years and years. Okay, so another thing that's very important for you is always keep whatever that you have collected for a case organized, so that you can always go back to the same case again and again and again. Okay, so as I am speaking, I recognize that some of the cases that I investigated a while back, that I have already lost all my material. Okay, so if the lawyer were to call me again, I have to tell him, "Sorry, I lost all that the only thing I have is in my mind, what I have done, or maybe the electronic version of the report." Okay, but I cannot bring out the old data to prove one way or the other. But that's what happened. Okay, so that's real life. Okay, and the investigation. So the investigation is the process where your engineering skill really come to play. Okay, so everything that you have learned in your structures class, okay, or your geotech or construction and so forth, you have to think which one would be the most important tool to help you improve your case. Okay, and unfortunately, most of the time you just don't have enough, so you always have to learn. Okay, and learning is actually a very important part of the evidence. Okay, so sometimes your references that you have read becomes part of your evidence. Okay, so the lawyer will come to you, the opposite side will ask, "Okay, how did you come up with this conclusion? What analysis have you done?" You show them, "Okay, I have done the moment distribution for this particular multiple beam problem." Okay, and then they will say, who teach you moment distribution. Okay, even though it's something that you think is very basic, they will come and ask you the basics. Okay, because their job is to prove that you are not expert enough. Okay, does that make sense? So you should always have your toolbox ready, and you can reference. Oh, I did this calculations based on I don't know, Hebel's, second edition, and then this is the example. This is how you do a calculation. You show them. Okay, so all these are very important, and unfortunately, you don't know where the litigation will go, what direction the arguments will go. So you just have to always be prepared. Okay, collect as much of your background materials as your evidence as possible. Okay, and next thing is, a lot of those mega-sized investigations are not done by one person alone. Okay, so you may require other partners. Okay, and it's always good to work as a team, especially for forensics, because one person's opinion sometimes can be biased. But if you have multiple people, you become a more convincing, collected mind scenario. Okay, and so, but then you don't always find people of like minds, like backgrounds. Okay, sometimes you may require specialized people. Okay, and so forming a investigation team becomes really, really important. Okay, you may be involved metallurgy if you're dealing with steel structures, fire burn down structures. You wanted to know what kind of steel they use in the initial construction. Okay, so those are experts that you can call upon. So make as many friends as you possibly can. So you can always call on experts. Okay, geotechnical engineers, concrete material problems always is a challenge to identify because it involves a lot of chemistry. Okay, and good photographer is also very important. Okay, so I took a lot of pictures over my career. Okay, because taking pictures is very important. But you should have. I'm not a very good expert in, especially as I'm aging. My eyesight gets worse. Okay, and so you cannot get a good picture if you have to take the camera this far away from yourself. Okay, but you should always have some basic skills of taking scientific photography. Okay, if you will, and then test specialists such as non-destructive testing. Okay, those are always very important. Okay, site visit. You wanted to be able to get to the site as quickly as possible, but unfortunately, many cases that you don't get that opportunity. Okay, because especially in the cases where life and safety are associated, you are not allowed to be on site because you are not the first responder. Okay, people who are trained in safety and accidents are usually the first one to get in. Okay, and unfortunately, when they get in, things change. Okay, they may be to put out the fire. Firemen may be spraying water, and that may dilute the evidence for your case study. Okay, so there are many. Ideally, you wanted to be there, be the first person on site, but usually that may not happen. Okay, so that adds to more challenges to our work, but that's just the nature of the beast. Okay, and then you of course have to investigate. I mean, we are civil engineers. Okay, so safety should be the first thing in our mind. So when you go to a construction failure site, make sure that you yourself is safe. Okay, you don't just climb because you wanted to take a certain picture and endanger yourself. Okay, so having that common sense of safety is extremely important. Okay, I don't know if steel toe shoes is prevalent here, but in America, whenever you do an investigation, we always require you wear very strong shoes. Okay, definitely no slippers and no open toes. Okay, because you may get into another litigation because you hurt yourself. Okay, and document everything that you find. Okay, so always carry a camera. You may find me as a person. I always have a camera in my pocket. Okay, not just a cell phone. I mean, nowadays cell phone is so prevalent. You can take a lot of pictures. But old habit, I like to carry a camera. And my camera is special because it has GPS. Okay, And so I can tell, based on the GPS location, where that picture was taken. Right? And in fact, some of our investigation that involve NITT, that we optimize the use of GPS camera photos to do investigation. Equipment. Okay, so there are some very basic equipments you should always have. Actually, Kartik, can we get into CN's office? The key is not, even the main office doesn't have, because I left a lot of.
Maybe when you go this Saturday, you can ask Misha
For his office key. But main office, there's nobody has. Okay.
His room key he only has.
Okay.
Since February, we haven't opened his room.
His office, okay.
We
Because,
can,
yeah, in 2014, when
you bought
we,
some kits.
yes, we have several,
It's in his room, I
yeah,
said.
okay, yeah, that would benefit the school. Otherwise, we may have to go to the lab, borrow. Yeah.
We check it in the NDT lab.
Okay, okay.
Sometimes he must have transferred that down.
Okay,
But
okay.
once I saw in his cabin.
Uh-huh.
it was there.
Yes, yeah, yeah. So we
Then we will ask
Yeah.
Misha to see that
that borrow the key. Okay.
will do.
Uh-huh. Okay. But so you want to know distance, so tape measure is the definitely. And then there is a thing that a transparent plastic. I think I left mine with CN as well. It's called a crack meter. Okay, so it can measure the crack openings of concrete. So those are very handy stuff you can put in your pocket and you carry to any inspections. And those are the basics. Okay, and then camera. Sometimes you may require surveying tools. Okay, but those are a little more costly and hard to carry with you. Okay, so those are the very, very basics. And video cameras sometimes can be helpful because you'll be recording something other than just a still. The sound, even communications you with the locals or witnesses can be replayed and help you remember some of those observations. Okay. But whenever you do recording, you have to ask for permission. Okay, so you know, just a random neighbor that stands there and watching, and then you go and talk to them, you know, then they would deny, no, I never know this person, you know, and that would be an issue. So always ask them, and you know, so there are skill sets that you need to learn when you interrogate a witness. Okay, so because you are not the owner of the place. Okay, you really, other than the legal representation of a forensic investigator, you have no right at the property. So you don't want to offend anybody. Okay, so when you talk to people, make sure that they are on a friendly terms so that they can divulge as much information as possible. Okay, and so you should prepare yourself. Hard hat is always required. Okay, especially for construction failure cases. Always wear a hard hat. Okay, gloves so you don't cut your hands and legs, and so always wear long pants, no shorts. Raincoats if it's raining. Okay, sunshade. I like to wear a baseball cap, you know, because the sun sometimes will change the way that you see things. Okay, and also working under the sun can be very hot. Okay, so you want to protect yourself. But there are many. I actually have a very cool hat that has lights on the front, kind of like a miner's hat. Okay, and that is very helpful when you have to go under a dark area. Okay, so all those are handy tools. So your cell phone that has light, or bring a pen light. All those are very important handy tools. Okay, you can never be fully prepared, but prepare as well as possible. Okay. Carpenter pants is very useful because carpenter pants has a lot of pockets. Okay, so you can put pencils and everything. Yeah. Clipboard with papers, so document. Okay. Voice recorders, as I mentioned, it has the same function as a video recording. And blueprints if there's available. Okay, so blueprints is very important because you can just compare right away that you know what happened, whether they did the construction properly or not. Okay, I'm hoping that one day virtual reality would actually happen, So there are many construction companies in the U.S. that are now investigating to use virtual reality. So it's not uncommon you go to site and then you're required to wear either Google Glass or something, that you actually can walk in and virtualize everything. And that is one of the reasons why we wanted to train you guys in laser scan data processing, because understanding what that does becomes, I'm very sure, one day become very useful in your profession. Okay. And plastic bags is very important, so you can collect evidence, especially for geotech. You want the soil samples, so put them in plastic bag. They will be disturbed soil, of course, unless you bring your own soil sampler. Okay, Shelby tubes or something. Okay, and as we already talked about lights and lanterns. Some basic calculators, so you can measure distance or conversion. Okay, handy tools, hammers, screwdrivers, knives. Okay, when you saw maybe the failure is due to erosion or corrosion, collect some of the samples so you can do some basic oxidation test in the lab. You can do that. Okay, and the ladder, if required, that you have to get higher up. Okay. Sometimes you are allowed to build up scaffolds, especially for construction failure sites. Okay, and so that requires more people going. Okay, you almost have to have a crew going there. So that involves a different level of management. Okay, so it's not just one inspector or a group. Now you have many people on site. So what you need to do at that is to manage your people, to make sure that they don't disturb the evidence. Okay, tell them how you want it set up. Okay, and only set up to the limit that is required for your investigation. Okay, hoist for lifting and so forth. Okay, document as much as possible using photography. Okay, taking a lot of pictures. During my 2014 investigation, we actually learned a new technique. Okay, so we're doing individual house inspection. So we take pictures around the building, consistently, and then there is a software that you can actually generate a 3D imaging of the building in 3 dimensions. So I'll show you some of those cool pictures, videos, okay? And those are very good for replaying, because being able to see the entire thing in 3 dimensions helps you understand a lot more about how it was damaged, especially in the wind or earthquake case, okay? You can pretty much tell, okay, this is the direction of the wind coming in or flood coming in. And that's why that part of the building has more damage and so forth, okay? So a lot of those very detailed. And of course, you can collect as many data as possible, but then document them, catalog your data. Becomes extremely important, because you have to go back and reference each one of them. It's a very time-consuming process, but if you do it right, then when you go back to your old data, it becomes easier to do so. Okay. And then visual examination. Okay, so as you go through your investigation, you will be making observations. Okay, so your notepad becomes extremely important. You write down as much notes as possible as you go through inspections. Okay, and if you have handy documents such as blueprints, take a lot of sticky pads and then put in as much reference as possible, so that when you go back to the office, you may not have a second chance to go back, because every time you go into a site, that site condition is time step 1. Okay, because the moment you leave, things change. Okay, the next time you come back, many things will look different. Either people has been doing cleaning up, or other investigators come in and they disturb the site, or the next time you come in, maybe 3 months, 6 months, a year from now, trees will grow, grass will grow. Suddenly, everything looks totally different. Okay, so every time you are there, that one time stamp becomes extremely critical. Okay, and so you have to document on photos. I like to use PowerPoint to manage my photos, the digital photos, because I can always draw an arrow. This is the failure, this is my observation, and this is such and such. Okay, so those are very important. And put as much descriptions as possible. Okay, so we will be doing our own investigation, but I want to show you some pictures. So this is in China, Nanjing University graduate campus at another city, Suzhou. Okay, so it's a brand new building. So when I got invited to go to that building, my friend was like, "Hey, look, this is my building." He's the dean of the graduate school at that campus. This is my building. I'm going to do this here, and I'm going to do it there, and so forth. But when I go, as an inspector, my eyes automatically focus on the problems, right? So I'm like, "Hey, you have cracks on your building," and he's like, "Well, I see cracks. There is a crack." So when you look at that crack, what do you think caused the crack? Obviously, the cracks on the facade, right? So there are tiles on the exterior of this building, and then the crack happens to those facades. Okay? Does that show you anything structural? Huh? Stress relief? Strain gauge? No, there's no strain gauge. I mean, if we put strain gauge, maybe we can measure something. But just looking at the crack pattern, can you tell something about what failed here? Possible temperature differential, because all these tiles are bonded to the concrete structure, right? Yes, the stress either in the bonding elements or the exterior material would change, right? And then so the differential displacement will cause the tiles to crack, because that's the weakest element. They are non-structural elements, right? That doesn't tell me that there is a structural problem with the beam or the column. Does that make sense? Okay. But however, even with that, say, look, notice that this particular crack goes horizontal all the way through. Not necessarily. Not necessarily due to moment or movement or anything. Yes, that could be a structural joint. And as a result, some structural joints allow more displacement, or that joint is rigid, and then the components are less rigid, and then you will see a systematic damage. Okay, and so those are very important. If the crack pattern would be more like a diagonal, then I would be very concerned. Okay, because diagonal failure, that may means a punching shear kind of, or the wall has some kind of displacement. Okay, but being able to visualize this kind of damages is a learned process. Okay, and that's why when I teach this kind of class, I always tell students the best service you do to yourself is go look at as many buildings as possible. Okay, and train your eyes, always look for problems. Okay, because you will see, hey, there's a very strange crack on that beam. Okay, why? You ask yourself questions. Okay.
Temperature cracks are quite difficult to heal.
Very difficult to heal. Yeah, and this city is one of the notorious for very hot. Yeah. Mm-hmm. Yeah. So when they put the
knowing the topography, the climatic conditions, we have to choose the appropriate materials when we do.
Exactly. Yeah. Yeah. But in China, this is very common. Yeah.
Quite more common here also. Even in NDT we find.
Yeah. And that's
they do some patch of works, and again what happens, it propagates.
Yes.
When the next season comes,
it will happen again.
It propagates.
Yep. And so construction technique, construction workers, skill level are all very important. Yeah. And another thing is, so in America, when we do high-rise buildings, we use concrete cast in place. We build the formwork and then we put concrete. But in China, they are more common to use concrete bricks, even for very high-rise building. And so I'm wondering, I don't have a lot of experience with concrete bricks, but maybe that would dictate the failure modes. What do you think? Because we in America we see less of this kind of failures, but more on the edge, because all the concrete will cast in one uniform, and if you were to build a building with bricks, then they may be laid at different time.
Actually, the self-weight will increase. No, sir?
Yes,
When
the
you
self-weight,
do that,
yeah.
Maybe because that might be a criteria. If they haven't designed the wall load carefully, that it might be because of that. You make some joint areas.
Right.
Especially if it happen, these sort of things might be because of the overload.
Right. Yeah. And if you are not
Normally for
even.
bricks, it will be 15 to 18 kilonewton per meter cube. This will be around 24.
Right.
So.
Yeah. That may be.
Nowadays, here in our place, the trend is they are not going for clay brick or earthen bricks.
Yeah.
They go for fly ash bricks.
Fly ash brick. Yep.
Is abundantly available now, but now as per the census report, in the next 5 to 15 years, it will degrade. The protection, the coal production and everything is stopped now.
Oh.
So almost all the materials was taken by several cement factory people.
Okay.
They do the blended cements and other things. So fly ash bricks is coming more popular for the past 5 10 years.
Okay.
It is going well. But no such things is found in fly ash bricks. One more thing is the area.
Yeah, maybe fly ash bricks are less thermal, lightweight. Okay, yeah. So the building overall weight becomes less. Yeah, I think. I'm not sure in China how much they use for fly ash concrete.
In China, it will be abundant because lots of
coal fire. Yeah. Yes. Yeah. I know they do a lot of research on fly ash concrete.
For the future scenario, there's a plan to import coal from China also. There is a proposal.
Yeah.
I don't know how feasible it is.
Okay.
So they are planning that.
Tamil
Nadu, other than LLC, Neyveli Lignite Corporation, now that is totally stopped now.
Okay.
It's becoming declining.
Yeah.
Production. So in Tamil Nadu, it is fully dependent on only NLC.
Yep. Yeah. Wind and more renewable now. Lignite. Okay. Yeah. Okay. And here are some construction failures for sure. Notice that this joint and this joint looks different. Some of the things has already fell out. Okay. The water insulation and so forth. So. When you go into a building, those are ancillary failures. They are not in any way safety or functional related. Okay, but nonetheless, they can go to the contractors and demand either they repair this or bring them to lawsuit. Okay, and of course you get even more problematic. Drainage or air conditioning and so forth. And that is that building was brand new at that time. Okay, for those failures. Okay, eyewitnessing. Okay, so we talked briefly about interviewing witnesses, interrogating. Well, not really interrogate, but most likely interview. Okay, so you will have people on site, and then you have pictures that hopefully they have taken throughout the process. Okay, and demanding pictures and so forth from people are usually very difficult, okay? Unless the contractor is very confident the pictures had no harm to them, they will not share those information, okay? But having those information are very helpful, especially before the failure happened. And testing program, okay? So you need to know where are the damages, and then you need to be able to do some in situ test, okay, in the field. Okay, so for example, when we say testing, you may be using a hammer, a Schmidt hammer, to tell what is the strength of the concrete on site. Okay, and then plumbing, if the door is out, all these are part of the test plan, okay? And you need to document those because those are your data. Those are data that you generated, okay? And it should be part of your record, okay? And every time the court reference to any of those data, they will identify as your data, okay? And then let's talk about some other testing methods that may be required as for civil engineer, okay? So there are always some kind of destructive testing method. You may be getting a part of the materials, maybe do a coring, and then bring the concrete back to the lab or steel beam, and then you can do a destructive testing to determine the various parameters, yield point, ultimate strength, and so forth, okay? Toughness, those are very common. Sometimes you may require to determine the temperature effect on the structure, on the component, okay? How much was the exposed temperature and so forth. So you collect those information. Those will damage the specimen, okay, for sure. And then there's non-destructive testing, okay? So non-destructive testing methods are actually consist of a very broad range of systems, okay? But because non-destructive testing is not originally a technology developed by civil engineers, we are now slowly adapting ourselves and modifying many of those tests into civil engineering applications, okay? So, for example, the rebound hammer, okay? And many of those are, you have to perform in a very systematic way, and some of those are only good for laboratory use, okay? So if you were to perform in the field, whether the data that you collect is accurate, that's most important, okay? Or whether it can be admitted in the court, okay? So if you take something in the lab and then you perform outside, people will bring up a lot of questions, okay? This technique has never been used in the field. How do you know that your results is accurate? Okay, then you have to be ready to defend yourself, okay? Electromagnetic scan for rebars is getting very common in the US because it's very easy to perform, but it requires a big setup. Okay, so for example, if I wanted to detect and determine how the rebars are distributed on this floor, I have to mark up on this ground. Okay, so I'm in a way disturbing this area, right? But then you take that and then you slowly scan. It takes a long time, but it gives you a very nice image of where and how deep the rebars are, and even the size of the rebar. Okay, and so this kind of tools are now industry standard. Okay, so if you have a floor, for example, this building, that there's a failure. Okay, maybe it's because they don't have sufficient rebar, or the rebar was not designed properly. So being able to see in a non-destructive way the size of the rebars underneath, it becomes a very useful tool, very powerful evidence, okay? But then, those tools are only as good as how you perform. So those rebar detectors usually are very sensitive. So you have to roll it in a certain way, okay? And you cannot change direction, because you change direction, then the data XYZ becomes different, okay? Then your data becomes very bad, okay? So those are very tedious, and usually if you want to perform such a test, you have to inform the lawyer, okay, to let them know, hey, I'm going to bill you 100 hours of just mapping off the rebar underneath. They'll be upset, okay, because, there's a lot of time, and all you do is just show me a picture of how the rebars are distributed, okay. So there's always, on the business end, you have to judge how much you really want to know the truth, okay. It's like in the movie A Few Good Men. You can't handle the truth, okay. So lawyers cannot handle what requires a forensic engineer to actually find the truth, because that would take a lot of time and a lot of money. And many times they wanted the easy way out, okay. And so if you are the engineer that can be easily not very professional, then they will look for you, but then they will lose the case. Okay, so there's a check and balance always. Okay. There are several advanced techniques. So, forensic investigators are always on the lookout for new techniques, new methods of investigation, methods that are making your life easier, new instruments that easier to carry to the field. Okay, so these are some of the new techniques like acoustic ultrasound methods, mechanical vibration. They are not necessarily named based on its actual product name. Okay, so you have to realize that Schmidt hammer is a very specific name for the hammer technique for localized concrete strength testing. Okay, but there are similar equipments that are called something else. Okay, and then acoustic emission, and then there are non-mechanical wave-based methods. So you have to understand a little bit of physics whenever you purchase one of those equipment. Okay, because if you are not an expert in what you do, you'll come up with data, then people can ask you tons of questions, and then suddenly your credibility drops. Okay, so your credibility in a lawsuit is based on your able to demonstrate how expert you are. Okay, so if you have a piece of equipment that you used, new equipment, you don't know a lot. Okay, you just want to try and then earn money, then you're in danger of losing your credibility. Okay, so you have to very, very again, there's a balance. Okay, because unless you investigate a failed case, right? So no matter how expert you are with the equipment, you're still one step beyond being a true expert, right? Because you never apply it to an actual failed case. But you can tell the lawyer, I know this equipment inside out. But they say, because you have not applied. A good example would be nuclear concrete. Okay, so in a nuclear power plant, they have concrete that are very thick, a lot of reinforcements and pre-stressed members and so forth. Almost none of the NDT techniques will work for nuclear concrete. Okay, because it's just so deep. The penetration of the X-rays or infrared is not possible. Okay, but then there are always people trying. Okay, so they will be proposing, I will use infrared camera to scan, and then I can tell you where the problem is. Well, whenever you use an infrared camera, you always see something. Why? Because the moment you scan the wall, you scan this part of the wall, the sun will come up at different times. The thermal gradient on the wall has already changed. Okay, so every time you do an infrared scan, you always have something. The problem is to interpret the results and show that something means something is the challenge. Okay, for nuclear concrete, my student has done, even if for a 2 feet thick wall with a lot of rebars, even if you have 1,000 degrees differential of the thermal gradient moving, you cannot use an infrared camera to see anything. Okay, because it takes a long time for heat to go through a concrete. Okay, and so it's not necessarily the right technique for that kind of application. Okay. And then there are several of those techniques are traditional non-destructive testing methods. Okay. And then there are
something happens, sir. Some accident happens.
Yeah.
That sort of structure. What will be the remedial thing? What as an engineer, what sort of preliminary examinations we can do for that sort of?
Almost
problem.
There's almost nothing you can do. Yeah, so we have closed a number of aged nuclear power plants near my city. I'm not directly involved, but my student were, and he went in there. They were shocked. I think it was maybe a 70, 80-year-old nuclear power plant. When they opened up, they found the concrete behind the surface are all cracked out. Very, very bad condition. But nobody know. Because you do any NDT from the outside, you can't see any of the problems. So that becomes a really, really critical issue. I don't think there is a solution yet.
Can we do with anything like laser?
No. because it's so thick, there's no deformation on the outside. You almost cannot see any problem. It's only when you open from the new, the radioactive rod part, a lot of damages. And then now they are talking about construction problem. So a lot of those bad concrete may have already existed when the plant was just built, but nobody know because it was so deep inside of the concrete. Yeah, so it's a big problem today. Yeah. Okay, some traditional techniques like chain drag and coin tap actually is very useful. Okay, so I don't know how many of you have experience of chain drag. So it's literally a steel chain that was lay on the ground, and then you just pull it. This is most of the time applied on a bridge deck, and then you just walk. And then if there's a void in the concrete deck, the sound will change. Okay, and so you have to have trained ear to listen to that kind of sound change. Okay, so those are very non-electronic based techniques, but very effective. Okay, but you can't do it on nuclear concrete, because if you hit the hammer, you don't hear the acoustic coming back. Yeah, it's too thick. And then ultrasound require higher level of understanding. Okay, the technician or the people who apply the technique need to have a high understanding of the limitations of the technique. Okay, especially the guided wave technique, such as the pulse echo, that you need to be able to tell, what direction the wave is propagating and so forth. Okay, so those require certificate inspectors. Okay, and then acoustic, just a little bit elaborate on what the technique is about. Okay, so acoustic ultrasound method is a low frequency method. Okay, anytime acoustic is associated, usually refers to the low frequency band, usually maybe 1 or 2 kilohertz and below. Okay, and earthquake for buildings are usually 0.1 to 123 hertz. Okay, so you realize that in the vibration domain, you have a very broad band, and then we have different categories of the technique, and that also relate to the sensor type that you use. Okay, so vibration sensors, all of them has a limited bandwidth. Okay, only from a certain frequency to certain frequency. So you have to use the right sensors for the right kind of problem. Okay, so it requires you to be an expert in those areas. And then the mechanical vibration, as I mentioned, is very low frequency, usually 50 hertz and below for civil engineering application. And the shaker excitation is a very important part. So buildings naturally have some kind of movements. Okay, even this building, as we sit here, we don't feel anything because it's so low. Okay, however, if you wanted to be able to detect damage, you need to be able to shake the building. So you need to use a shaker. Okay, and the shaker also come in different range. So you need to know, apple to apple, the right frequency sensors to detect the right type of shakers for the building or bridge or whatever structure you were talking about. And the hammer is usually the more preferred technique, because when you use a hammer to impact, okay, you are generating a broadband wave. Okay, and that broadband wave usually has many frequency components. So when you hit on the ground, one hit you cause many modes to happen. Okay, so that's the preferred method. But again, you have to be trained in doing that kind of testing. Okay, so all those are required techniques. Okay, acoustic emission is the system itself actually creates vibration. Okay, so it's like when you tear a piece of paper, okay, that sound is actually a strain energy release, deformation energy release from the paper. Okay, so if the paper, small paper, the sound will be higher. A bigger paper, the sound will be lower. Okay, so by using electronic instruments to listen to this sound, you can actually tell many things about the structure. Okay, but it will only happen if the structure is damaging. Okay, so using this technique becomes critical and tricky. Okay. Electrical and magnetic method is actually a very, very useful technique. Okay, so in my laboratory, we are actually now developing a technique called self-sensing concrete. So what we are doing is we embed metallic stuff in concrete, okay, so like steel fibers, and then we pass electric currents to the concrete. I'm talking to you specific, okay, and if the concrete is being stressed, okay, the electric current would actually change its voltage, or the resistance, electric resistance of the concrete become less, because when the material become denser, and so the electric current will become less. And that is actually my solution to nuclear concrete. Okay, but there are still many things that we have to investigate, because concrete itself is also acting as a capacitor. Okay, so you can actually use concrete to store electricity, because concrete is made with what? Water and cement, right? So the water molecules that exist in concrete would actually become polarized. And polarization of the water molecules become a capacitor. So you can pump a lot of electricity to the concrete and actually store electricity that way. Okay? So you can literally, and there are people who do that, they put 2 electrodes in a concrete cylinder, and then they charge electricity, and then they can reverse and then generate electricity. It's really, really interesting, okay? So there is a project in China, supposed to be top secret. No, it's known. So they dig a very deep hole and then pour a lot of concrete, like several kilometers deep. And then the purpose is when lightning strikes, they use that to store lightning, electricity. You know, so it's really smart. Okay, but it's not easy to do. Yeah, very, very, yeah. So it takes some understanding of physics to do that. But my interest is electric and magnetic methods actually can be reversed to study the damage to a system. Okay, and another research that we're doing in our lab is actually using electromagnetic methods. So there are some, especially steel ferric materials, you can make them into permanent magnets. Okay, so if you imagine those dust are placed into concrete, then all you need is just use electromagnetic multimeter device. You can measure the polarity of the magnetic field in the concrete, right? If that changed, that means your material changed. Okay, but these are still very early on in its development. Okay, but you know, you can use your imagination to use all the concrete steel properties to do some kind of damage detection. Okay. And optical grid method. So this actually has 2 fields, and in fact, when we start talking about LiDAR, okay, we will be actually we will not, but we will be talking about many possible applications of optical methods. So optical methods only measures the surface of a structure, right? But when you have deformation, even slight deformation using optical methods, because when you measure any kind of optical methods, light travels at nano. In other words, light wavelength is very short, right? So they are very sensitive, because when we look at structural failures, it only is significant. Every structure when you build, okay, there is always a few millimeters of difference, right? Because we can control the construction resolution to very high level. But when you have a displacement, usually that's quite significant. So using optical methods, that is the most sensitive method that we can measure deformation, okay, because you are measuring in nano. But you cannot just use regular light, okay, because regular light, they are dispersive, because there are so many bandwidth involved, okay, and also it's all visible light. So you need to use laser, which is narrow band. You only one band or two band lasers, or using other techniques such as moire. So what is moire? Moire is the change of light pattern. Remember from high school physics, okay, that when it goes through a certain material, transparent material that has all optical different densities, and then as a result the light scatters. Kind of like my hand, you can see the different light level, right? Because the light going through, that looks like because of the glass in between, okay, that looks like a moire, okay. So moire is the pattern of this change. So if I start moving my hands, you can see based on the change in the shadow that, you know, something has happened, okay. And so that is one of the technique called shadow moire, okay, or hologram, okay. Hologram is you create an artificial surface on a material, and then when the material starts changing, the hologram will be able to pinpoint what are those changes. All of these are deformation based, okay. But deformation is extremely important, right? Because as we discussed yesterday, we don't never measure force, stress or force. But the only thing we measure in real life is deformation, okay. And optical methods also has another area of benefit, is that its area, okay. The light shines is one area. So using ruler measurements, you have to measure many times, but light, it goes all, okay. But then to analyze those data, you have to use computers. You have to know algorithms. You have to know how to program, okay. So that goes a little bit beyond civil engineering, you know, but if we have to learn, we have to learn, right? And that's why Navani will be dedicate one whole day on just teaching you guys how to do LiDAR point cloud analysis, okay? And then high-speed vibration measurements using high-speed cameras. In 2015, when we have the structural health monitoring workshop, we invited one of the professors from Hiroshima, Ichi. And in his lab, they use very high-speed, megahertz cameras, okay? And the camera would be so fast, he called his technique the Superman eye, because he can use one camera and see simultaneously many points. Because it's so high speed, it's almost as if he's looking at many points simultaneously. Okay, there is a fine optical difference in time, but it, you know, for civil engineering application, it's not essential. And at that high frequency, you can even measure vibration. Okay, so those are new techniques out there that we can apply to forensic application. Okay, and then video CCD cameras for very slow motion, like, you know, a crane coming down. You know, you can use those information for many applications. Okay, but that requires image processing skill. Okay, and then infrared, as I mentioned. So infrared method is depending on the temperature release. Okay, so it's a very important thing to understand. Infrared is not measuring the temperature property of that material. It's the temperature release of that material that you're measuring. Okay, so when we apply infrared on a structure outdoors, usually we do it at night. Okay, it's when the temperature is cool and then the sunlight already hit off the concrete, and when the heat is coming out, then you are seeing what's underneath on the structure. Okay, and X-ray and radiography are really new techniques that are now readily available on handheld device. So X-ray camera is only a little bigger than your laptop. Okay, so you can use it for, but they have a limit on how deep they penetrate. Okay, so there are many limitations on this kind of techniques. Chemical methods. If you wanted to do tests on corrosions or chloride intrusion, you know, there are chemicals that you can apply on the surface of the material. So you should be familiar yourself with all those techniques, okay, as an inspector. Okay, the benefit of destructive and non-destructive testing obviously is that destructive testing, you destroy the evidence. Non-destructive testing, you preserve the evidence, the specimen, okay? But then non-destructive testing, the challenge is that you need higher training, okay? And without that kind of training, your test is almost worthless, okay? And then the other thing is the equipment are usually more expensive, okay? Okay, and another thing that associated with non-destructive testing better than the destructive method is most of those are electronized, okay? So the equipment are usually associated with a microprocessor or computer. So you collect the data. So the data becomes digital evidence that you can apply readily. So that is another advantage of non-destructive testing method. That is extremely useful, okay? Limitations, again, the destructive testing methods only on the particular evidence, and once you're done, it's done, okay? You cannot repeat, okay? Non-destructive testing, you can go back and do it again and again and again, okay? But non-destructive testing, again, it needs skill. You have to be somebody who knows the limitation of that particular method, okay? And then so you do it right, okay? More of those limitations. And then petrography is another higher level required because it actually tells you the source of damages to at the material level. Okay, so petrography is a specialized area. The expert has to be able to read the XRD, X-ray radiography testing methods, or the SEM. Okay, so if you wanted to know whether they use the right mix of concrete, they can use X-ray to see what kind of chemicals were bonded, whether you have enough calcium oxide or other elements in there. Okay. Core sample. Okay, so every time if you have to collect a sample on site as a forensic engineer, you have to request a permit. Okay, so the owner has to allow you to collect core samples. Okay, so which again limits on how much you can do. Okay, so maybe they will allow you 1 or 2. So that's your only evidence. Okay, so what can you do to prove your study becomes extremely critical. Okay. And okay, so next is literature study. So literature study is a very integral part of forensic investigation. Okay, if you are dealing with a historical structure like Dr. Shen and I have investigated some of the historical church in Tamil Nadu, and some of them are 100, 200 years old. Okay, so what happened if the building has, for example, you're investigating water damage? Why there's water damage? Was there a flood? Is this building in the potential flood zone? When was the flood happen? Okay, and so you need to be able to establish a history. And where do you get those information? Newspapers, archives, okay, the memory of the priest at the church, okay, or at the temple. And so you start to realize that this is a process that is almost inductive. Okay, so you have to understand there's inductive reasoning, deductive reasoning. Okay, inductive reasoning means you collect a lot of information. You don't know where you collect the information from. And based on the information, you start creating your opinion. Deductive reasoning is if A is 1, B is 2, C is equal to 3, that means A plus B must be equal to C. Okay, that's deductive reasoning. You base on 1 event, 2 events, 3 events, and then or 1 thing, 2 thing, 3 thing, and establishing the sequential or the consequence causal relationship. That's called deductive reasoning. Okay, so it is not true that we are always using deductive reasoning. In fact, most of the time we use inductive. As a matter of fact, because of the search engines, okay, the internet's availability, we found people use more inductive reasoning more than deductive reasoning. Okay, and that is a good thing because most of engineering students, when you graduate, you are good in deductive because homework is deductive. Okay, if I analyze this beam, one loading at this point, and then the reaction, it has to be the answer must be the same, everybody. But the inductive is not, okay, because your collecting information is always partial. So your conclusion are not always the same. Okay, so you really realize that in forensic investigation is about logic. Okay, about logic working under the guidelines of law. Okay, so how logical can you be? Okay, becomes very, very critical. Okay, and as a matter of fact, I suggested at one time that in the forensic curriculum, students should take a class in philosophy, especially logic reasoning. Okay, but that probably requires too much from for engineering students. Okay, yeah, we have more just detailed information like manufacturer's certificate and so forth if you're dealing with machine failure. Okay, correspondence is extremely important. Okay, so as I mentioned, the one of the case studies that I did this year on blasting, we actually go back and look at the blast records. Okay, so they have done several blasts because they have to build a dam and acquire a lot of material. So I collect all these blasting records and then all the vibration data from each blasting, and then trying to see if there's any patterns. Okay, and that would sometimes reveal very important information. Okay, and then the correspondence. If the email shows, hey, on this certain date, somebody mentioned, hey, we have an issue. Okay, and that may be the cause of the problem of failure. Okay, so you have to look at what is the issue they are trying to address during the construction. Maybe it was difficult to do blasting. And then the conclusion is, hey, let's put a lot more dynamite and then make a bigger hole. And then when it blow up, the vibration becomes much larger than the limit state. Then buildings get damaged. Okay, but people didn't realize that was a problem because they are busy doing construction. And so all these are your critical evidence in correspondence. Okay, so being able to build a time history of what happened is extremely important in forensic engineering. And okay, so as we mentioned, you have to formulate your hypothesis. Okay, what happened? And fortunate or unfortunate, a lot of times during forensic investigation, you will be talking to enough people that kind of limit your investigation. So I have never involved in a case that I have to question, a meteorite dropped and caused the damage. Because nobody told me there was a meteorite that hits on the building. An alien come and did something. You never wonder that far, but if you really wanted to do a thorough investigation, you should consider all possibility, right? But fortunately, when you talk to people, slowly you start to already know these are the few causes. Okay, so you limit on how broad you have to investigate. Okay, and then finally you have to write a report. Okay, the report should have a detail on how you did the investigation, what was the history of what happened, and then finally what is the logic and the reasoning that led you to do a certain conclusion. Okay. And then usually what happens after that, after you submit your report, you will just wait. Okay. Then the lawyers from both parties will start talking. Okay. So they will be arguing among themselves, and they will decide how are they going to proceed. Usually defendant is the one that decides. We're going to fight it through because we know we are not at fault. Okay, so they will go to court. Then you'll be called. They will ask you for the time. When are you available? Okay, then you'll go to court, and then you'll be sitting in the chair, and then they will start asking you a lot of questions. Okay, so there are many different levels. Arbitration would be, they will just talk, and then they just resolve the whole thing, and then pay you, and that's it. Okay, so that will be easy, right? But sometimes it goes a little bit deeper. Okay. At the end, let's talk about Tacoma. Okay, another famous case. Okay, so everybody going through structural engineering all have learned that this bridge collapsed because of resonance. But the problem goes a little bit deeper, okay? And the reason is because how it fell, okay? So you can see that part of the bridge collapsed, okay? And what happened is people believe the bridge was too long and too narrow, okay? And as a result, the dominant, the vibration modes dominate its failure mode, okay? And then, unfortunately, at that one day, an extraordinary wind came by, okay? And then, as a result, the bridge collapsed because it hits its resonant frequency. That's what every physics, every mathematics professor would teach you. Every structural class, that's what they teach them. That's how I teach my students. Until I realized that this is a very much still debated case, okay? So what's happening? Well, these are just some pictures. So one of the things is that other than the bending mode, there's a lot of torsional modes, okay? And so was it fell in torsional mode or bending mode? That's what most people were debating. And the most recent paper, last night I tried to find that Japanese paper. Unfortunately, I was not able. They were claiming actually the failure mode is the cables, not the bridge deck. Okay, and the reason is because if the bridge were to fail in the resonant modes, then it will probably most likely be completely disintegrate rather than fail at a certain point. So the reason it fell at a certain point is because the cable actually gave up.
It was not stiff enough.
Yes, not stiff enough. And then also because of the stretching of the cables. Okay, and so that is a very important conclusion. Okay, but it's still being debated. Okay. So after this incident, the significant contribution to civil engineering is actually we do more aerodynamic, aeroelastic of bridge designs. Okay, and so many people say, oh, and even in the design guideline, there's dictate on the length and so forth, so that you make sure you're not hitting the resonant vibration frequency. But the problem is, we always assume the wind gust hits the bridge. The wind gust and the bridge vibration must be in the same mode. Okay, and that's one of the arguments is that when you have a burst wind coming, it's not a resonant wind. It's a pocket of wind that hits the structure. So there is no such thing as a corresponding, not like earthquake. Okay, and so that pretty much throw everything that you have learned about Tacoma Bridge out of the window. Okay, so that is a very strong argument. Okay, and so aeroelastic instability and flutter are all just theories. Okay, so recent years those are being rebutted. Okay, and of course these are the most common lesson learned, and this is also written in Delat's book. Okay, so those are classic solutions, but the reality is, even today, there are several arguments. So the original theory of the Tacoma failure was by von Karman. It's 1940. Von Karman is one of the Nobel Prize winners in electrical engineering, and he is the one that proposed that the bridge fell because of resonance. Okay, but then Scalan, which is a very famous wing engineer, his book on wing design is classic. He proposed that a strong wind force on the bridge that amplified the resonance. And this is where people argue. You cannot have a resonant wind that at such a high magnitude, okay? Because usually those high burst winds are just pocket winds, okay? It's like a blast, like a shock wave. There's no resonance. So pretty much throw his theory out of the window, okay?
Maybe when the heavy wind has hit on the particular surface, the cable might have lost its...
Yes, but then we need to focus on the cable vibration, not the structure vibration, because they are separate. Yeah, that's the Japanese paper's conclusion. Yeah, and then a green paper suggests so Green is a physicist, so they actually come up with the negative damping. In other words, they believe that when the bridge was under resonance, the damping actually become negative, means there's an amplification factor. Okay, so the bridge at that point, even if you just blow on the bridge will collapse. That's because there's no, the damping actually helps the vibration, you know. So that is a very interesting theory, but it was done by physicists, and it's not going to be easy to be accepted by civil engineers, okay? And then the more interesting thing is people are actually improving on the original video. So there were 2 videos existing, and now people are digitizing the video and then adding component to it. So they were able to capture from the video some of the sound effects that people has been not paying attention to, okay? And then they add color and they add many things to the video. So now they are creating this monster, but still being debated, okay? So if you one day you guys become a professor, don't make the same mistake I make. Teach the class as if you don't know why it failed, okay? But aerodynamics is definitely an important subject, okay? But this is definitely not a classical example of aeroelastic instability issue. Okay, I think that pretty much is very convincing. Yeah. Okay, so this is what I have, and if you don't mind, I'm gonna indulge a few minutes of more of your time, and talk about what you are preparing to do. Okay, so we actually found a old sample project from 2012. So again, this is at that time our class was actually very big. I think we have maybe 60 students, and some of them are from physics department. So you have to understand that people who do forensics engineering in this setting are not necessarily just civil engineers. Mechanical engineers, they do the non-destructive and their forensics, okay? And then physics people who understand a lot of the NDT principles like wave, optics, and so they are also heavily involved in forensic engineering, okay? And I think those are the students that show at that time, okay? So this is a report by a group of physics students that they present their work. There's a total of 12 slides. Okay, and again, we are doing the same investigation on the same building. So it'll be very interesting to see your results compared to what they have done at that time. Okay, so they found foundation cracks, wall cracks, improper roofing, poor water outlets, and unhealthy environment. Okay, so these are the evidence. So this is a foundation crack. So they found the crack they're talking about is actually here, the separation. Okay, between the soil and the building itself. Okay, and they show more evidence, even some of the soil separated from the foundation, okay, of the structure. But you know, we are civil engineers. We know these are not dictating any issue of instability. Okay, it's just because of the drainage of the soil. Okay, but this wall cracks and so forth will be more critical. Okay, so but those are always the painting that expose the cracking. Okay, so because of, I think most of the walls are bricks, so the crack pattern actually will be very interesting for you to analyze. Okay, some of those column beam shear movements and punching shear are something that maybe you can observe. Okay, and then another thing that is very important is the attachments to a building, like pipes. Okay, so sometimes pipes, why are they separated from the structure? Okay, there is a reason. Okay, so those reasons are not necessarily structural, but definitely it indicates a certain problem. Okay, so don't ignore a separated pipe or part of the window frame come out. Okay, all those may have some meaning. Okay, and then of course, I hope we don't see that, but at that time there's big crack, you know, and in fact I think they measured like some of those are several millimeters wide. Pretty scary. Okay, is that a structural failure or is that just material? Okay, you have to express your professional opinion. Okay, And then, yeah, you can see more cracks. And improper roofing. That's what they call improper roofing. Okay. And poor water outlets. I can guarantee you will see some of those even today. Okay. So those are more hygiene and aesthetic issues. Okay, than actual problem. I mean, if somebody will walk by there, may trip, okay, then cause an accident. So it's safety issues. Yeah, poor drainage, and then even pipes that are wide open for no reason, okay. And then unhealthy environment, so the pond water, mosquitoes, okay, or you know, just very poor water. You know, I don't think it's potable in any sense, but the trapping of water. Oh, you know exactly what I'm talking about here. Yeah. We're not here to embarrass our colleagues, but you know, you just go and observe problems, okay? And then trash, okay, yeah. And actually, I think this time coming to campus, I see it improve a lot. Yeah. So yeah, this is a much better campus now, okay? And then for the presentation, you report, okay, the building is safe. That's what they agree upon. Okay, but there's negligence, so they should have covered the cracks and damages and so forth. And they need proper reconstruction of the water outlets, okay, which everybody agrees, and the roofing. And then finally, they suggest that there should be regular inspection. So this goes beyond our typical forensic, which is only problem finding, okay? But they make recommendation, which is good, okay? By the way, that is also a very, very important aspect. Okay, so again, using the case study that I did this year. Okay, actually, I did the deposition this year. So I did 2 investigations. One was 3 years ago, and then 2 years ago, and then 1 year ago. So they pay me to do multiple inspections. The reason is because there are several building cracks, and we want to know whether they are opening. Okay. And but before the deposition, the lawyer asked me, so they have to quantify how much is the damage, how much they wanted to request from the opposing party. And I told him, very specific, I only do inspection. I don't do repair. Okay, and I definitely do not do pricing of repair job. Okay, so it is okay for you to designate your qualification. Okay, and it's fine. So the lawyer would go to a contractor and ask them, hey, if this is the kind of scenario, what do you need to do to repair the house? And the contractor would tell them, this is how much money I would request. And that's how they get their pricing. Okay, so we all have our limits. You don't have to do everything and provide every answer, because the more you tell them, the more you are at risk of being discredited. Does that make sense? Okay, so that's very, very important to explain to people. Okay, so we do expect you to prepare, and because we only have 2 groups, at that time I think we have 6 groups, so we limit everybody's group to only 10 slides or 12 slides. But for your group, we encourage you to provide as much as you think professionally you need. Okay, but still your presentation is 10 minutes. Okay, yeah, so that's all I have for today. Any questions? The 19th. Yeah. So I encourage you to spend a little bit time as a group and talk about, you know, when you want to get together, do the inspections, when you wanted to do. You are not talking tomorrow, right? Yours is Thursday. Okay. So maybe Thursday, because his lecture will be short, okay, including training. Oh, by the way, so normally you will require them to download certain free software, right, to process the LiDAR data. So do they require to bring the laptop, or they can do it afterward? Okay, but we will share his email, so you have any questions, ask him. Okay. And I'm hoping that tomorrow I'll give you all the PowerPoint. Yeah, then we can print them so they have the material on their hands. Okay, yeah. Okay, any questions? Okay, then otherwise then split into groups. We're waiting for the...
Visit, they can, it's their flexibility. They can visit anytime.
Right, right.
They can go around and they can see.
Yeah, you can choose your own time, set it up, okay.
Maybe when we give it as identical civil engineering department, we will get more views.
Yeah.
Group A will get give their views, and Group B will be
getting their own
giving,
views.
yeah.
Okay, yeah. Right. Do you, so now we will let you guys break into groups, get to use your group a little bit, yeah. What is the time today? I mean, the lunch arrangement?
We can go, sir. It's,
are they also?
We can go, sir.
Oh, no, I mean for them. What is
after lunch?
No, lunch.
Lunch is ready right now.
They also go?
Yeah,
Oh,
we have to go.
okay. They'll be with us every day.
With us.
Okay, good. Okay. So you have a choice: either do it here or do it at lunch. You guys can sit together, eat, and then talk.
You can.
Is the bus here?
Department also.
Yeah,
bus
is here. Okay,
Bus is
okay. So we're ready to move. Yeah. Maybe do it over lunch. What do you think? Okay. Yeah. Let's go then. Yeah. Navani, you want to collect your? Yeah. Oh, before I forget, I bought some chocolate from America. So.
But it should have been.
Yeah, I should have been a little early.
So you can.
Here, have some.
Thank you.
Yeah. Pass it on. Yeah, pass it. And also, before I forget, I want to thank Dr. Kardik for.
Thank you. Thank you. Your favorite captain.
Yeah. Thank you so much. Yeah.
I think this is. Thank you.
Yeah, this is our university.
Okay.
Yeah. You can take
it will be very helpful for me when I go for some field inspections and
Yep.
other things. Thank you very much.
Yeah.
You almost had luck.
Thank you. Did everybody get?